glad there are a couple of people who are interested in these sort of things, as some who have been to my talks before. I mostly talk about operational aspects. I'm not much of a coder. Just a really short introduction. I'm working with Punkt.de in Germany since the company was founded. I'm one of the owners. We started as an ISP, and today what our marketing department came up with is open source digitalization. So we try to help customers with transforming internal processes, but instead of building it all on commercial products, use open source for that. We built quite some know-how, for example, in identification, authentication management with Keycloak. We do a lot of PHP portal applications. And whenever we can, and whenever we host it, we run it on FreeBSD. We have 36 employees at the moment and 2 office locations. I myself, as I said, I'm an owner and co-founder of the company. I do FreeBSD since 1993. And I've always defined myself as a network and systems engineer. So I take products, look what they can do, and then combine products and features in interesting ways to come up with innovative solutions. But in recent years, I've come more and more into actual coding, contributing to OpenSense and stuff. But still, mainly it's how to manage FreeBSD systems, not much how to code FreeBSD kernel stuff or so. We run about 100 physical servers with over 1,200 customer jails. So our standard hosting product is a jail. This jail, we name it the proServer, contains everything and the kitchen sink. So there is Apache, NGINX, Caddy, what have you, MariaDB, Postgres, Java, PHP, Perl, and then the customer just picks what they want to run, service enable, service disable, whatever, and we take care of all the updates, maintenance, backups, restore, rollback, and stuff like that. Our challenge, we've run our own data center since 1998, and currently we run it at Telehouse in Frankfurt. And part of the management, layer 2, we have already outsourced to a friendly company whom we work with since also 1998 or something about that. Plusline, they're great. So they do all the layer 2 and uplink and electricity for us, but we still used to buy servers, deploy them, put them in the racks, install FreeBSD on them and stuff. And that's becoming more and more painful, because as a small company, if I order a server, it takes 2 weeks to get a custom configured server from some of our reliable suppliers. We have to stock spare parts. We have to either drive to the data center or have some other operator on duty to do hands-on maintenance. You have the lifecycle management. You switch out the server platform, and when you have a new generation, completely new generation of hardware, suddenly you also have a whole stock of spare parts that you can just throw away or sell at eBay or something. So hardware is not fun. Can't we virtualize it all the way? So, and hosting is a commodity nowadays. You can buy a dedicated root system with your operating system of choice about everywhere. So what we tried is, how far can we push this? Because we need, of course, we have customers with special needs, with high availability configurations, with local load balancing, with dedicated local firewalls, with private VLANs and everything. So the question was, can we do this in a commercial environment like provided by Hetzner in Germany? Michael said, is this going to be a Hetzner marketing talk? A little bit at the first, and then we'll go into the technical details, and it won't be, hopefully, anymore. So why did we pick them? They're located in Germany. They're reasonably big and well-funded, so I hope they will be there in the next couple of years. Located in Germany, so by law they are GDPR compliant, which is important for us because we need to be too. And they have multiple data center locations. Products are virtual PC, so cloud or dedicated server. They call that product Robot. Intel or AMD, your choice. NVMe or spinning Rust, your choice. Gigabit uplink, flat included in their dedicated server offerings. electricity included in their dedicated server offerings, and they can do surprisingly flexible modifications if you order them. If you order a stock server, just standard configuration, they will deliver it next business day. If you say, okay, I need 2 more network interfaces and a private wire and stuff like that, it will take them a week or so. That's good. One example about the pricing, AMD Ryzen 16 core, 128 gigs of RAM, 2 NVMe SSDs, uplink 110 per month. That's sharp. And so we started moving our business from the private data center and from our servers whenever a server was outdated and needed to be replaced, instead of buying a new one, or when we got a new customer and a new order, we deployed them at their DC. They have a rather nice UI for managing all that stuff, so this is our current situation. 45 or something systems, and this thing has power management, inventory management of reverse mapping, and stuff. Unfortunately, but I'll get to the technical details later, so just drop that sentence. Back to topic. Okay, all dedicated servers to Hetzner, install FreeBSD, keep our own private cloud Ansible-based infrastructure, and profit, hopefully. And it all starts with installation. When I get a new system from them, as I said, they have great web portal management, power, reset, offer a rescue system, of course Debian-based. And then we stumble on 2 issues. KVM only on request. So contrary to cloud systems, the dedicated servers have no IPMI, no console, no nothing. You can order it and they will provide it for free, but it will take from half an hour to 2 hours, depending on demand. And then we will have it for up to 3 hours. So that's not quite as convenient, but still workable. And they have officially no FreeBSD support. So what to do? We have depenguin.me. I guess one could talk an entire presentation about how that works. This is also the URL of the website. Depenguin.me is a script that bootstraps an MFS-BSD image in KVM. So you boot into Hetzner's rescue system, which is Debian-based, then download the depenguin.me script. It boots FreeBSD in KVM, maps all local block devices it finds into virtual disk from first to last sector. And then you can run BSD install just the regular way and install FreeBSD. This is just awesome. And it works with other hosters too. So quite a thing to note and to keep in the back, in the tool bag for future installations. The good thing about Hetzner is they are not overtly hostile to people running other operating systems. They are completely cool with us running FreeBSD, and if I open a ticket and say, all right, we have this hardware issue here, they don't go the Dell or Lenovo way and say, you're not running our supported OS, and please run this diagnostic tool first, et cetera, et cetera. I'll send them the kernel demessage output that says, look, this NVMe disk is broken, and they replace it, no questions. So they're cool with people running whatever they want. They just have no internal FreeBSD know-how. For setting up a system remotely that you will then reboot into a live system, I found this nifty trick, and I don't know if this is really documented anywhere. I stumbled upon it by reading the source in the RC system. We have an ifconfig_default for rc.conf. That's awesome, because when I install from the virtual machine running inside Linux, I don't know what the names of the network interfaces will be. And sometimes with them it's IGB, sometimes it's IGC, sometimes it's IX, we get all sorts of mixed hardware depending what they have on the shelf. So this does the trick and plain works, bringing up the machine. So what's an uplink in the data center look like? Of course, we have dedicated servers, they nail down the environment for their customers as much as possible. You always get with each server, you get a /64 IPv6 free or included. And you can have an optional single IPv4 address for a pretty small fee if you need it. Sometimes we do, sometimes we don't. And then if you need IPv4 addresses for hosting, and I'll show in some of the next slides how to save IPv4 addresses if you just host web applications. Then you can get /29, /28, /30, but fees are increasing, so it's not astronomical, but the IPv4 addresses are worth real money now. They nail down in the switches the MAC addresses, probably use static ARP for IPv4. I have not tried to find out how they do it with IPv6, but they just route the entire /64 towards your server's MAC address. And that's that. You share a /26 or sometimes a /27 with other customers, and you can see their ARP requests in IPv4, but that's not a problem. I mean, this is the outside interface of your infrastructure, so it's considered internet. Yeah, that's that. So firewall accordingly, or lock down your services accordingly. This is public network. You have a static IPv6 gateway. It's a linked local address. I consider that best practice to have linked local default gateway addresses for IPv6. I really like that. And it's the same for every server and every network. It's always FE80:1. So that's easy. In our own data center, this is from my proServer architecture presentation from Paris. We just bridged all the VNet jails directly to the network and gave them public IP addresses. In Hetzner, we can't do that anymore because we only have one MAC address, so we cannot use VNet interfaces with different MAC addresses. So what we do is we just disconnect the bridge from the physical interface and have the host be a router. So the jails are routed through the host machine for IPv4 and IPv6. Yep.
Why are you bridging the different customer jails together instead of running the host, which is already a router, as a router for each jail? Why bother with bridging?
Because VNet and IOCage do that and don't do routing. Tooling limitation. We did not, as I said, I'm an operator. I combine tools that are there, and at the time, IOCage, BSD did not yet exist, was the most advanced and IPv6 and multi-protocol and multi-interface capable jail manager around. So we picked that. We have some vague plans to refactor that, and I would go to plain FreeBSD jail.conf, because now we have the jail.conf.d and we have one file, and I really liked your presentation about it. But at the moment, we are limited by what IOCage can do. So, and you see that jail over there to the left, that's a gate 6.4. So conserving IPv4 addresses, we do NAT 6.4. But let's have a look, let's get a little bit technical for a moment, because there's also an interesting nugget in here. We rename the physical interfaces to a standard configuration for all our hosts. So the uplink is always iNet0, and then you can see a /26 IPv4 address. That's what Hetzner gives us. And the default gateway is also an address in that particular /26, so that's Hetzner. Then we have the bridge. We name the bridge jail0 because that's where all the jails are connected. If we have IPv4 for the jails, then we have a /29 at the very least, because that's the smallest network that makes sense. And then we have an IPv6 address, like something prefix 2/64. And the interesting nugget that's hiding in here, we get 1/64 from Hetzner. Just a second, let me finish first. 1/64 from Hetzner. But the host itself also needs one IP address out of that /64 on the external interface for egress, for downloading packages, for NSX, for DNS lookups and stuff like that. And it has been common wisdom that you cannot put IP addresses v4 or v6 from the same prefix on two different interfaces. When IP NCP was first invented, the first idea was that the IP address should be a node identifier. But at that time, all links were point-to-point links. And when Ethernet was introduced and we got broadcast domains and we got bridging and all that stuff, then it was quickly decided that it should be an interface or a broadcast domain identifier, and you should have different networks for different interfaces. But you can, in FreeBSD, actually assign an IP address from the same prefix to a different interface, as long as that interface is, e.g., a point-to-point interface, or one with a link local default gateway, when you pick a 128, or in the case of IPv4, a 32 net mask. So you can borrow a single address from that prefix that is configured on the bridge.
Do you really configure unique locally assigned IP addresses, or did you replace the global IP with?
I replaced the global IP with that beef.
Okay.
So these are all global unicast addresses. The 1/64 by accident. That beef is just the generic placeholder, at least in my presentations and historically. So no, that's a global unicast address and a global unicast network, and we borrow a single address for the host itself with a /128 net mask. That's similar to what in Cisco IOS would be IP unnumbered, and then borrow an address from a different interface. I have not tried if you could actually use the same on both with that /128. Now NAT64. So IPv4 addresses are expensive, and most customers only run web applications. So they're interested that their customers can reach their applications via IPv4 and IPv6, but the jail does not necessarily need to have a globally routable IPv4 address. So we use an SNI proxy in that Gate64 jail for that, and then some IPFW magic in the jail. This is the Gate64 part. So we allow 80 and 443 to the external IPv4 address of the jail, of the Gate64 jail. And we allow TCP out to any target that's in that IPv6 prefix, to ports 80 and 443. And then we just, for security, because we don't need it, we deny everything that is not needed. We deny the jail to reach out to other websites on other servers. And then IPFW has this nice NAT64 function. So you can create an IPv4 prefix and then translate everything that's going out from the IPv6 prefix to any of the NAT64 IPv4 and IPv6 addresses. We NAT to IPv4, and everything that's coming in, we NAT the other direction in. So is everybody familiar with the concept? If an IPv6 host, IPv6 only host, asks for a DNS record of quad A for a system that does not have any, and you have a special NAT64 DNS server or DNS64, then the DNS server will answer with a fake quad A record in this FF9B prefix range. And then the IPv4 address will be embedded in there, and then a NAT64 gateway can translate IPv6 to IPv4. So that's how that works. And in the jail part, and I think this is quite clever, we have the outgoing route. So we have the NAT64 prefix, and we route this towards the Gate64 jail, so it can get translated. And then in NGINX, we have two additional hosts on ports 87 and 57. I don't remember how we came up with these numbers. And they have the same configuration as the production web servers for IPv6. But additionally, we activate the proxy protocol. Proxy protocol enables a web server and a proxy to transmit stuff like the host name in the query and stuff like that. And whenever we get a connection on our IPv6 address from the proxy system. On port 443, we instead translate it to port 57. So we get in NGINX the proper proxy protocol aware server entry. Yes, Jan?
Do you deal with HTTP2 clients who reuse a TCP connection to talk to different host names?
Wouldn't work. Haven't noticed any so far. So the flow of the connections is the SNI proxy. An SNI proxy is a thing that can do TLS to TLS. It just does the server name identification negotiation at first, and then relays the TLS connection. And so we get a request on port 443 to the SNI proxy. The SNI proxy knows the host name. It can look up the IPv6 address for the target host name in DNS. So that's why it's absolute mandatory to have quad A and A records for the final destination. Then it relays the request to the IPv6 in the jail, and then our IPFW magic translates that to port 57, and there we have the special server configuration that speaks proxy protocol. Because on port 443 in the jail, we have a regular server that answers all requests that just come via IPv6, because it's a web application that's globally reachable. So there is of course a server listening on the IPv6 address. So this is the standard part. We've been doing this in our own DC. This is one host up to, say, 100 or so-ish jails. Runs well, and the customers are really happy with the way we do the updates by simply exchanging the entire image that is underlaying the jail. We shut down the jail, switch the nullfs mount points. We use nullfs still, and then boot up the jail, and we have an instantaneous, with 20, 30 seconds downtime, update of each jail. Now, pushing infrastructure needs a little bit further. Hetzner allows you to order additional network interfaces for private connections. Can be a cable or an unmanaged switch. For that to be possible, the servers need to be in the same rack. So if a customer wants to, they don't do cross wires, cross racks, but they are really flexible as long as you stay in, as long as you stay in the same rack. And you can reserve rack units for a reasonable monthly fee, single digit something. So if you're planning ahead for growth, they say, okay, please 6 rack units for servers for this customer. And then you know you can always interconnect them. And then you add a bridge, you attach jails, and you have a private interconnect. As I said, we use I/O cage. So the setup of the interface is nothing specifically tricky. We just have an, I see, sorry, I forgot the bridging code. But just, we have this IGB1 interface, and then we put a bridge on that, and then we can connect jails. To connect jails to more than one interface in I/O cage, you have this interfaces variable, and then you can say, please, VNet 0, connect to that bridge, VNet 1, connect to that bridge, VNet 2, connect to that bridge, as much as you want. And then you can get set the addresses in the syntax like this. So for VNet 0, we have that address. For VNet 1, we have that address, etc., etc. That one is a unique local address, the second one for the private network. So, and this was one of the first requirements when a customer said, all right, big enterprisey customers, we need a relay from your proServer infrastructure into our own data center, and there must be a dedicated firewall, and it must speak IPsec because enterprise. Okay, so we put an OpenSense on a dedicated system at Hetzner, ordered a second network interface. Then we have the proServer host who also got a second network interface, and told Hetzner, please just run a cable. and that works really well. And now to get really fancy, they offer something that's called vSwitches, virtual switches. And this way you can create not only limited to a single rack, but you can create over their entire infrastructure, physical servers and cloud instances, flat networks. From a customer or host point of view, it's based on VLANs. So you create a VLAN on your uplink interface to connect to vSwitch. You can have up to 5 vSwitches per server, up to 100 servers per vSwitch. So that's quite a bit of breathing room. The vSwitch itself is free. If you need public IP addresses because you use the vSwitch for a public internet-facing part of your infrastructure, of course, the public IP addresses are available for a fee. Internal traffic doesn't cost a thing. External traffic, 1 terabyte included. And above that, €1 per terabyte per month. Quite reasonable. I think we have never exceeded the 1 terabyte limit so far for any customer. And the vSwitches support multicast. Yay! CARP, we can do high availability load balancing open sense clusters in their DC. And that was our first installation for a customer where we used the vSwitch at all and were tested extensively if CARP and multicast would be supported and if everything worked. So as you can see, these open sense boxes, they now have a 1 gig uplink, which comes with every server you buy. They have a second 1 gig interface with a cable for the PF sync and the RPC for the clustering of the 2 nodes. And they have a third interface. You can order up to 2 network cards, etc., with 10 gigs connected to a private switch. And then we have all our hosting servers. The customer currently runs 6 and plans to grow up to 10, also connected with 10 gigs to the same switch. And then we can run public IP addresses, IPv4 addresses with CARP on that external virtual switch and have a really highly available open sense configuration, which of course is not so much about the availability in terms of entire host crashes or anything, but I can do updates without interruption. It's a second. We lose 1 ping or 1 request or something like that if we update the open sense cluster 1 node at a time. That's really quite nice. And what we do in our proServer and Ansible infrastructure is that we use the standard uplink of the Hetzner hosts for management. In that particular case, they are IPv6 only, which is enough for us. We run dual stack since 2001, 2 or something, entire company. And then to this backend in the private network, it's IPv4 only because the customer likes that way, and they're a little bit old-fashioned. And then we relay IPv4 requests through the OpenSense via H8 proxy to the individual nodes and can do all sorts of replication and high availability and stuff in there. Second example is the most complex I've built so far. This is our new shared infrastructure. Our product is either a dedicated machine, and then you can put as many jails on it as you like, but we manage the jails. You just say, okay, I need 1 more, and then we deploy it from Ansible and then tell you the IP addresses so you can log in. Or if you buy a shared proServer, you get a single jail. The customer regularly does not get any access to the hosts. So for customers who run only a single jail, we also have the requirement, can't you do HA replication, at least with manual switching in case an alarm goes off because an entire machine fails or anything, but at least something, we have that in the book of standard requirements and stuff like that. And in former times, we always said, if you want HA, you need to buy 2 dedicated machines. But of course, sometimes the project just doesn't have the budget for that. So after a little bit of planning and internal talks, we came up with shared jails. So many customers are supposed, this is quite new, so we have 5 or so on them here. Now, many customers are supposed to share these things. We can deploy standard jails. That's the link at the very top or at the very bottom. Just the architecture I showed you with the bridging and the routing, and you get a public IP address. Or I can give jails, or on that 10 gig link, which is a cable, I can create as many VLANs as I need, 1 per customer, and then connect their jails there, and they have a private link for replication and whatever mode of high availability they want to do. And then for the uplink, we go into a vSwitch, which goes to the OpenSense cluster. Again, there's a simple cable for sync and RPC, and then we have CARP as the, say, IPv4 default router for all the jails on these hosts. And then another vSwitch, which goes to the internet with IPv4 and IPv6, and again, CARP. And all of this works flawlessly and very smooth. I'm quite satisfied with how that is running. We don't have any servers so far with more than a 1 gig uplink. We just don't have the bandwidth requirements, and the vSwitches are not limiting that bandwidth in any way. So 1 gig of throughput, no problem. I have not yet had the opportunity to test 10 gig uplink and then putting it through a vSwitch. Host configuration again, that easy. We have the regular network interface stuff, and then you simply put a VLAN on your uplink interface. At Hetzner, vSwitches can only be connected to the uplink of the host, and then put additional cloned interfaces in there. So again, I have here a private pref0 named bridge on that VLAN that you can see in the second paragraph. In this particular case, the host itself does not have an IP address on that particular VLAN because it doesn't need one. We just connect the jails, and each jail's got an IP address. So for us, trying how far we can push the envelope of what we can do, and if we are as flexible as in our own DC, I must say yes, indeed. And I mean, Hetzner also has a custom everything department. You can buy a rack and consulting and then service to your specification with network cabling and everything, switches and what you need from them. They are a professional supplier in that regard, but we wanted to try and stick with the simple standard product that we can order and manage ourselves through their web console. Not least, of course, for cost reasons, because the custom stuff involves humans working on that, and they want to be paid. And in their standard control center, everything is automatic. So our conclusion is, yep, great success. Specifically, because of scale, we have far better mean time to repair and stuff like that. Even if you count in the overhead that when I get an alarm, I first need to open a ticket with them. They have a 24/7 phone hotline, and they have reaction times that can go up to 1-ish, 2 hours, but not more. But they have inventory. And if I say, okay, this server has crashed the 3rd time in a couple of days, I suspect the main board has this and that issue, and provide some D-message output or something. Again, they don't insist that I first run a Linux-based test suite or something. They simply swap the thing, and we're up and running in no time, very, very quickly. So that's definitely good. So I promised I would not do too much Hetzner marketing, but I have one more thing. I contacted them, asked them if they wanted to possibly explore how they could expand their FreeBSD audience, maybe start to support FreeBSD, maybe send an engineer so we could do this talk together. They friendly declined, but Here's a coupon code in case you're interested in trying their offers. Take a picture with your smartphone. That's worth 10 euro, and it's valid 50 times or 49 because I had to try it at least once. Yeah. You need to activate this until end of tomorrow. Yes, that is short notice. I don't know why they did it that way, but once you put that into your account, you have these 10 euro to spend over the next 3 months. So if you like it, take a picture and that's it. Okay, questions? None? Nice. Should you come up with some in the future, or should you need some help? Of course, I'm always willing to give away advice and communicate and everything for free via regular channels. If there is a customer and a budget and you need serious consulting from us, then of course my company is also available. It's my email address. The handle is from Blue Sky. I moved off of Twitter 2 years ago and don't regret it. And Blue Sky is a fine place if you like that sort of microblogging service. Thank you very much.